So we are talking about shear stress, shear strain. What is shear stress? Is force over area, but that force is not axial; it is lateral load. So my load is here, force, and my this area. You can do not make mistake. Do not take this area or this area. No, it is this area where you are applying your force. That force by area is shear stress. In axial case, we took a sample and apply force axially, and that stress was axial. So we got the shear stress. What is shear strain? After applying the force, if my material deforms like this, that means my angle was 90 degree. Now my angle is this. So what is the change in angle? This angle. So this angle is called shear strain. So we represent by gamma. We represent by gamma. How to find this angle? If you know this side, say it is delta, and if you know this side, say it is L. So gamma will be, or you can write this tan gamma equals delta divided by L. That is your shear strain gamma. Now we can extend it a little bit to make our life simple. Why simple? This concept valid only in proportional limit or elastic limit. Proportional limit. That means at the very beginning, when your deformation is very small. If your deformation is very small, okay, this is gamma. If your deformation is very small, that means gamma is very small. So you will agree with me. If gamma is very small, then tan gamma will be just gamma. Because if you use your calculator, you will see that that obviously it is in radian. So if your angle is very small, sine theta or tan theta is very close to theta, in radian. If you use the unit of the angle radian, then you can simply write gamma. No tan, no sine. Now we do not need sine here. I just wrote here sine just to refresh your memory. Sometimes you use this. Here we need only tan. Now why tan is delta by L? Tan theta means opposite divided by adjacent. So for this angle, this is opposite. This is adjacent. I know that you learned it in your middle school even. Okay, so shear stress, shear strain, you got it. What is their ratio? G is shear stress divided by shear strain. What is G? If I go to axial, you can remember what is E. Axial stress divided by axial strain. What was this? Young's modulus. Then what is Z? Shear modulus. Shear modulus. Okay, let me take a new figure because it becomes so messy. I'm drawing again. So for this case, your E was axial stress, axial strain. For this case, your G is shear stress, shear strain. What is this? Young's modulus. What is this? Shear modulus, or sometimes we call modulus of rigidity. This question in your MCQ test, so make sure do not forget. Like what is G? G means modulus of rigidity or shear modulus. Both are okay. What is this E? Young's modulus or modulus of elasticity. What is their connection? Is it same thing? No. Or also to say this modulus does not change with loading mode or rate or shape of the sample, because this is a material property. It doesn't matter how fast we are applying load, how slow, or if my sample is rod versus a plate versus uh, like similar, it can be a section, whatever it is, modulus is same. It's a material property, it will not change. This question is in your MCQ test. That uh, I exactly forgot the question, but the meaning is this: that modulus doesn't change with loading mode, loading rate, and shape of the sample. Shape, or maybe I can, in your question, it may tell geometry. The same thing is, it can be rod, it can be square. It become rectangle, no problem. Now I am trying square. So square, rectangle, rod, C section, sorry, angle section, C section, W section. You call it I, actually it's W, wide flange. Okay, forget the name. Shape doesn't matter. Simply, shape doesn't matter. Okay, then what is the connection between E and G? They are equal? No, because this is my shear deformation. This is my axial deformation. It is not same. The connection is, I forgot, but let me try to memorize. G is twice 1 plus mu. Mu is Poisson ratio. Is it correct? I do not know. I need to check your book, but to the best of my knowledge, it is correct. It is correct. The connection between G and E is this. Now, other question. Which one is bigger, G or E? Poisson ratio. Oh, Poisson ratio, we use the modulus. We do not consider the sign. Right here, no sign. Sorry, no negative sign. We do not use negative sign, because if we use negative sign, then there will be a big mistake. This is just a modulus value, just a value. Okay, if it is, what about the value? We know that Poisson ratio varies from 0 to 0.5. Whatever you insert here, this portion is more than 1. More than 1. We are dividing E by a value more than 1. That means G is always smaller, E is bigger. This question is also in your MCQ test. You can see whatever question in your MCQ test, I tell it sometimes somewhere. So if you do not follow it, you will feel lost. Now let me check with your book whether I did right or wrong. Hopefully right. Okay, so where is my cursor? Cursor come, yes. Yes, so shear stress, you can see we define shear stress P by area, and area means this area, and then shear modulus is stress over strain. Connection is G equals E divided by this. Now this equation is in your FE exam also, this equation. So there might be some question. One example, here we are applying shear force, but two ways. Why two way? This section was originally the shaded original. We applied force this way and this way, both. We squeezed it both way, and then both way got some distortion. Question is asking what? I do not know. Let me check. Average strain in at A. Where is at A? Now, question may ask anything, A, B, C, D, whatever. That question is not important. Important is to understand. So I can ask A, I can ask B, I can ask C, I can ask D. Okay, so before asking, let me check something. Originally it was this. After some time I squeeze this way, I squeeze that way. After squeezing, what happened? This portion is squeezed this way. Actually, it became longer. So there is some deformation here. There is some there. Okay, we will see that. But if I draw a how to draw, my drawing is not good, but hopefully you understand. It is twisting this way. So you will agree with me. This angle and this angle are equal because it becomes a rhombus. I know that you know what is rhombus. If we twist a square, it becomes this. If you twist a rectangle, it becomes parallelogram. Parallelogram from here to there. And square, if I do square, it becomes this. If I twist, if I twist, if I twist here, it twists here. But my main concern here, not to define this. My main concern is to let you know that this angle and these angles are equal. This angle equal. Now if I twist it uniformly, if I twist one side more, then there will be a change. Then there will be a change. So this angle equal, this angle will be equal. If I twist it uniformly. If I do not twist uniformly, then no, that will not be same. But this side uniform or no, this side and this side will be equal. At least this example will clarify that. Let me go to that example. Oh, this is just a like brief summary of your geometry. Where is my cursor? Coming. Cursor, come back. Oh, I found it. Yes. So the question asked at A, what is the shear strain? So what is the shear strain? Some deformation here plus some deformation here. So that is the shear stress. Now whatever the sum here, that will be there also. But you can see the deformation here is 3 millimeter, here is 2 millimeter. So this side and this side are not equal. But this side and this side will be equal. So if you find this, whatever A, that is your D. Now, okay, so we can find, now how to find it here? We'll find the angle here. How to find the angle? This side 3 millimeter divided by this 3 divided by this. What is here? 2 divided by this. This is 100. So my answer will be one side is 3 divided by 100, other side is 2 divided by 100. That is my tan phi. The total sum of this and this both. Now I can easily discard 10 because it is very small. It will be in radian, it will be the same value. Okay, come my cursor. You will see that example did the same thing. Let me see. Yes, see, theta equals gamma equals theta 1, theta 2. Theta 1 where? Here. 3 by 100. Theta 2 is here. 2 by 100. Then sum of this. I did not use the 10. You can use it. But that doesn't change your result so much. Okay, let me check it with my calculator to show you. If I use tan inverse, shape tan inverse 0.05, shape tan inverse 0.05, I got 2.86 degree divided by 18 times 3.14 gamma. Yeah, I got 0.0499 if I use the 10. But here 0.05, what is the difference? Same thing, 0.04998. So you can see if we use gamma or sorry 10 or no, it doesn't matter. Like then this concept shear strain, I will say it is not so important as important of the tension test. So again, it is a very simple concept. I should not say not so important. Let me turn off my video.